Welcome to Mr. Tompkins EdTech and my series of exam question compilation videos on key topics you might still be struggling with. This particular video covers geometry with algebra. I've taken related questions from my past paper walkthroughs and given them to you here back to back. These compilation videos will give you a deep dive on topics you are still finding challenging, giving you more of an overview, helping you recognise command words, identify key features and strategies, building your confidence and helping you apply these techniques for future papers. If you find it helpful, please give the video a thumbs up, it will really help me out. Also, if you haven't already subscribed to my channel, why not do that now? I'll be making lots of these compilations over the next couple of weeks and you'll get notified of these as soon as I upload them. Right, let's get into it. Question 10. A, B, C, D and E, F are straight lines? Yes, they are. Ava assumes that A, B and C, D are parallel. What answer should she get for the size of y? So if A, B and C, D are parallel, so this one is parallel to this, then what should she get for angle y? Well, if they were parallel, then this angle here and this one up here are going to be corresponding, aren't they? And therefore they're equal. So 2x plus 10 is going to be equal to 3x minus 2. So we can use that fact to form an equation in x that we can go on to solve. So 2x plus 10 is equal to 3x minus 20. So I'm going to collect the x's on the right hand side to keep my x's positive. If I take x to the other side, I'll get a negative value, so I'm not going to do that. And I'm going to move that over here to keep that positive as well. So that's going to give me 10 plus 20 is 30, and 3x take away 2x is x. That would give me x is equal to 30. So if x is 30, then our congruent angle then is going to be 3x minus 20 is going to be 3 lots of 30 minus 20. 3 lots of 30 is 90, take away 20 is 70. So then this angle up here then must be 70, and so y is going to be 180 minus 70 because they lie in a straight line, giving you a value of y of 110. So 110 if her assumption is correct. 10b says, in fact, A, B and C, D are not parallel. Angle W is 60. What effect does this have on the size of angle Y? Okay, right, so if these lines are no longer parallel, let's take those little arrows off because that no longer holds, then W is 60. Let's write in a different color pen so it's different from my working from before. So if this is 60 degrees, then so is this angle over here because it's vertically opposite. So 2x plus 10 is equal to 60. So 2x plus 10 equals 60. So that makes 2x equal to 50, x equals 25. Okay, so if x is 25, then 3x minus 20, 3x minus 20 is equal to 3 lots of 25 minus 20. 3 25s are 75, take away 20 is 55. So that angle is going to get smaller from 70, what we thought it was before. It's now going down to 55. Okay, so if that angle decreases from 70 to 55, it's dropping by 15, then my angle Y is going to increase by 15. That's going to go up to 125 then, isn't it? Okay, because those two angles are still going to have to add up to 180. So we're saying y is increasing, and I've got the working here on the diagram, but maybe the marker doesn't see it up there. I think it's probably fine, but just on the safe side you might want to copy that over into the answer box below. Question 6. This rectangle has a length of 4x minus 5 centimeters and a width of x plus 3 centimeters. And we're told that the perimeter of the rectangle is 46 centimeters. And we need to calculate the area of the rectangle. Okay. So we've got two things to do here. First off, we're going to form a linear equation in x using this perimeter fact here. Hopefully then that tells us what x is, and we can then go on to calculate the area of the rectangle after that, can't we? Okay, so let's do the perimeter thing first. Now the perimeter of the shape is the distance all the way around the shape. So if you start in one corner and you kind of stroll down one end, around there, and up there again, how far have you gone? Okay, so basically we're just going to add the four sides of the rectangle together. So my perimeter is going to be equal to 4x minus 5 plus x plus 3 plus another lot of those, isn't it? So plus another 4x minus 5 and another x plus 3. Okay, so then collecting like terms together. 4x, x, 4x and x, that adds up to 10x. And negative 5 plus 3 minus 5 plus 3 is going to be negative 2, isn't it? No, sorry, negative 4. Okay, so my perimeter is 10x minus 4. But we were told earlier that the perimeter was 46. So I can put that in there for p. So you can see now I've got a linear equation in x, which should be quite straightforward to solve. So taking this to the other side, or adding 4 to both sides, I'm going to get 50 is equal to 10x, and then dividing both sides by 10, I'm going to get x is 5. Okay, so now I know what x is. I can then move on to do the second part of the problem. Let's just find a numerical value for the length and the width then. So if x plus 3 is the width, then 5 plus 3, that's going to be 8 now, isn't it? Okay, and then 4x minus 5, if x is 5, then 4x is 20, take away 5 is 15. Okay, so actually I've got a rectangle of length 15 and width 8. So then its area is just going to be 15 times 8. What's that? 10 8s are 80, 5 8s are 40, so that's 120 then, isn't it? Don't forget units, centimeters squared. Question 10. 3 identical isosceles triangles are joined to make this trapezium. Each triangle has a base of b and a perpendicular height of h. Work out an expression in terms of b and h for the area of the trapezium and give your answer in its simplest form. Okay, so first off, we know that these are 3 similar triangles. So if the baseline of that middle triangle is b, then this also has to be b, and this also has to be b. So that's quite helpful, because then if this is from b to here, we know that this must be 2b from here to here. Now, the formula for the area of a trapezium is given by half a plus b h, where a and b are the two parallel sides and h is the perpendicular distance between them. Now, in this particular case, my a is going to be b and my b is going to be 2b. So I'm going to have b plus 2b. That's my two parallel sides, and my h is still h there. Okay, so just to make that very clear, my a is going to be this one up here, which in this case is b. My b of my formula is going to be this one here, it's my second parallel line, and my h is just a h. Okay, so there's that one there. So just subbing those things in, I've got half b plus 2b times h. Okay, so b plus 2b is 3b, so that's half of 3b times h. And I can just rewrite that as 3 over 2 bh. There's a kind of simpler way of writing that down. 10b, this diagram shows the same trapezium, and now we're told that this side here is s, and that the ratio of b to s is 2 to 3. And now we need to work out the perimeter of the shape in terms of just b. So we need to express S in terms of B basically. So if B to S is 2 to 3, then S is going to be, well, you're going to take B and you're going to divide it by 2 and times it by 3, so it's going to be 3B over 2. Okay, so S is 3B over 2. So if that's 3B over 2, that's B. So for along here was 2B, wasn't it, from before? And then up here is going to be 3B over 2 again. So adding those four sides together is going to give me the perimeter. So my perimeter is going to be my top line B, B plus my S, which we, plus my S, which we worked out to be 3B over 2, plus the baseline, which is 2B, plus the other slanty line, which is another 3B over 2. Okay, now 3B over 2 plus 3B over 2, so they're two halves of the same thing, aren't they? So that's going to give me 3B. So 3B plus 2B plus B is going to give me 6B altogether. So P is equal to 6B. 6B centimeters. Question 11. A large rectangle is made up by joining three identical small rectangles as shown. Now, it's not drawn accurately, so don't get your ruler out. We're told that the perimeter of one small rectangle is 15. Work out the perimeter of the large rectangle. This looks like a job for algebra. Now let's say that the width of one of these rectangles is W. Now I could write L there for the length, but actually if you look at it, this length here is the same thing as this and this together. In other words, we've got a rectangle which has got sides W and 2W. So I only need one unknown for this rectangle, not two. So I've got a rectangle with sides W and 2W. So then its perimeter is going to be those four sides added together. So my 2W plus my W plus my 2W plus my W going around the rectangle. 2W, W, 2W, 2W. So how many W's is that then? That's 6 W's altogether. And we're told that the perimeter of the small rectangle is 15. So we can replace the P there with the 15. And that tells me that 6W is equal to 15. So dividing both sides by 6, I'm going to get W equals 15 over 6. So 6 goes into 15 twice, remainder 3. So W is 2 and 3/6, or 2.5, isn't it? 2.5. Now, the question actually wants us to work out the perimeter of the large rectangle. So if we come back to our diagram then our large rectangle is going to be, from here to here, is 3 W's, isn't it? It's 2W and a W, which is 3 W's. And then down here is 2 W's. So it's 3W, 2W, 3W, 2W, which is 10W, isn't it? So the perimeter of large rectangle equals 10W, which is equal to, well, it's 25. So the answer is 25 centimeters. Okay, on the diagram below, we're asked to shade an area that's represented by the expression AD plus CD. Now, some of the measurements are missing, but we can see because from here to here is A, then this is also going to be A here. And because from here to here is D, this is also going to be D here. So AD is going to be this central rectangle along here, so that's AD. And then CD can be either one of the smaller ones at the end. I'm going to pick that one. That one there is CD. So between them, that is the area AD plus CD. Well, the next diagram, we need to show the area represented by D times a plus 2c. Now, a plus 2c is, well, here's c, and here's c as well, and in between is a. So from here through to here is a plus 2c, and then we already know that that's d down there, so a plus 2c times d is all of this central part here. The final part of the question asks for an expression for the whole area of the shape. So this part here is a times b, this part here is cd, we've got another cd over here, in the center we had AD, and then we've got another AB down here. So altogether we've got two ABs, we've got two CDs, and we've got an AD. Question 10. Here are a rectangle and a T-shape made from two rectangles, and you can see that some of the sides of these rectangles are given algebraically. Show that the rectangle and the T-shape have the same area. Okay, well, the area of the rectangle first off, it's very simple, just multiply the two sides together, so 7 lots of x plus 1, which, multiplying out the brackets, gives me 7x plus 7. And on the other side, the area of my T-shape is, let's take that, let's divide it into two rectangles like this. So then I can work out the total area by working out the two rectangles separately. So 2 lots of 2x plus 5, which is the top part of the T, plus 3 lots of x minus 1, which is the bottom part of the T. So I've got two single brackets that I need to multiply out here, and then I can collect the like terms together. So 2 lots of 2x is 4x, 2 lots of 5 is 10, 3 lots of x is 3x, and 3 lots of minus 1 is minus 3. So collecting the x's together, 4x and 3x is 7x, and 10x subtract 3 is 7. So you can see they are the same. Question 9. Towns P, Q and R are connected by roads PQ, PR, QR. PR is 10 kilometers longer than PQ. QR is twice as long as PR. The total length of the three roads is 170 kilometers. Alright, now this is not drawn accurately, so it's not about measuring the distances and using those. I'm going to have to work it out. Okay, I'm going to add these roads in first. They're not drawn, are they? So PQ is the road between P and Q. So let's just draw that in. PR is the road between P and R. So let's draw that in. Oops. Okay, now I'm going to assume that that doesn't actually drive into the C. And then QR is this road here then. They're not necessarily straight lines actually. It doesn't say they're straight. Okay, so we are told that PR is 10 kilometers longer than PQ, but we don't know how long PQ is. Now, if we don't know anything in maths to start with, then use algebra. So let's say PQ is equal to x. So I'm going to make this one here x. Then PR is 10 kilometers longer than PQ. That makes PR x plus 10 kilometers longer than x. And we're told that QR is twice as long as PR. So PR is x plus 10. So QR is twice that. So it's 2 lots of x plus 10. Now we're told that the total length of the three roads is 170. Okay, So what we're going to do is we're going to take our three expressions, x, x plus 10, and 2x plus 10. We're going to add them together, and that should give me 170. Okay, so let's just write that down. So I've got my x, x plus 10, and 2 lots of x plus 10. And I know that that is 170. Okay, these were my three roads, and this was the total I was given in the question. Okay, so now it's a matter of just kind of collecting like terms together and then see if we can solve this for x. Okay, so let's just remove the brackets over here to start with. So that's going to give me 2x plus 20, isn't it? Okay, I've still got my 10 and my x and my other x over on this side. Right, then collecting like terms together, what have I got? I've got an x, and a 2x. That adds up to 4x. And I've got a 10 and a 20. So that adds up to 30. So I'm going to get 4x plus 30 is equal to 170. So that was all my blue ones, that was all my purple ones, and that was the one I had before. Okay, so 4x plus 30 is equal to 170. Okay, so now I've got a linear equation in x. I can go on to solve it. Let's subtract 30 from both sides to start with. Okay, again, if you're wondering about which one to move first, if you think about what I was saying in the last question about bid maths backwards, it's the same when you are solving these sort of equations as well. You kind of unwind them going through the opposite order that you would do if you were actually working them out. Okay, so that's going to cancel with that, and it's going to leave me with 4x is equal to 170 subtract 30 is 140. And then I'm going to divide both sides by 4, divide by 4, divide by 4. What's that going to give me? So that's going to cancel with that, leave me with x. And then 140 divided by 4 is 35. Do it on a calculator if you're not sure, but I can do that in my head. X is 35. Right, have I answered the question? The question was, work out the length of PQ. Which is PQ? PQ is X. Oh, okay, that's easy enough. Then we have worked out the answer. It's 35. Question 12 shows a square whose sides have been given algebraically, and we need to work out the length of one side of the square. Now, these questions that mix geometry and algebra are becoming more and more common, so expect to have one a bit like this in your exam. So we know it's a square, so those two sides should be equal to each other. So I can equate them in an equation. So I can write down one side of my square, 6x minus 3, must be equal to the other side of the square, 3x plus 1. So actually all I need to do here really is solve for x. So I've got a linear equation in x that I need to solve. So let's just remove the brackets on the right hand side first. So that gives me 3x plus 3 over there. Then let's collect all the x terms on one side and the number terms on the other, which will give me 7x minus 3x is equal to 3 plus 3. 7x minus 3x is 4x. 3 plus 3 is 6. Giving me x is 6 over 4, which is the same thing as 3 over 2. Okay, done. Or are we? Just make sure at the end of every question you reread it, because I almost missed this. Work out the length of one side of the square. Sometimes when we find x we think, oh yeah, our job is done, but back to our square, our squares are not of side x. I've got one which is 7x minus 3 and one which is 3 lots of x plus 1. We worked out the value of x, so we haven't worked out the side of the square yet. We could use either one of those, so I'm going to use the 3 lots of x plus 1 because it looks slightly easier. So what's 3, what is 3 lots of, so when x equals 3 over 2, then 3 lots of x plus 1 is 3 lots of 3 over 2 plus 1. So 3 over 2 plus 1 is 5 over 2 times 3 is 15 over 2, which is 7.5. Question 10. This triangle is equilateral. Is the perimeter of the triangle greater than 1 meter? You must show your working. Okay, so I've been given 3 sides of an equilateral triangle, but each side has been given algebraically, and it's a different algebraic expression. So this one is equal to this one is equal to this one. So that means that those 3 algebraic expressions must be equal to each other. So 6x minus 10 has got to be equal to 4x plus 5, which has got to be equal to 10 lots of x minus 4. Okay? Now it's not so easy to work with like 3 parts of an equation like that. Can't really have 2 equal signs. So probably it's easier to work on one part and then the other part. So let's start with the first 2. 6x minus 10 is equal to 4x plus 5. So solving those, taking 4x away from both sides is going to give me 2x, and adding 10 to both sides is going to give me 15. So I think 2x is going to be equal to 15, making x equal to 7.5. Now if x is 7.5, what is the perimeter of one side? Okay, so let's take one of those calculations for the side, 6x minus 10 for instance. So what would 6x minus 10 be equal to? That would be now equal to 6 lots of 7.5 minus 10. So 6 times 7.5 gives me 45. And then 45 subtract 10 is going to be 35. So that equals 35. So that side is 35, and because these are all the same, that must be 35, and that must be 35 as well, even if they look a bit different. So the perimeter is going to be 35 plus 35 plus 35, which is 105. Is the perimeter of a triangle greater than 1 meter? Well, it's 105 centimeters, and that is yes. So total perimeter is 35 times 3, which is 105 centimeters. So the answer is yes. 105 centimeters is bigger than 1 meter. It's 1.05 meters, isn't it? Question 19. The length of a rectangle is 5 times the width, and we're told that the area of the rectangle is 1,620. So that is 1,620. We know that the length is 5 times the width, but we don't know what the width is. Let's call the width x, and therefore the length is going to be 5 times that. It's going to be 5x. So work out the width of the rectangle. Okay, so the area of a triangle, of a rectangle, is length times width. So using our diagram, 1620, the given area is our length, which is x, multiplied by our width. So 5x times our width, which is x, which is 5x squared altogether. So I've got a linear, quadratic equation in x here then, haven't I? So dividing both sides by 5, or cross multiplying that 5, I'm going to get x squared is equal to 1620 divided by 5, which my calculator tells me is 1620 divided by 5, 324. So x squared is 324. So then if I square root that, I get 18. So x then, now remember it's plus or minus 18 though, but in this case the negative value is not possible. So it is just a positive solution there. Then the width then is the shortest one. So it's going to be 18 centimeters. Question 9. Here is a cuboid. Assume that the total surface area of the cuboid is 200 square centimeters. Work out the volume of the cuboid. Okay. Well, the total surface area is going to be made up of the areas of the 6 faces of your cuboid. Okay. So I've got 2 identical faces here and here, haven't I? They're both going to be 5 times 5. Okay, so I'm going to get 5 times 5, and I'm going to have 2 of those. Okay, and then I'm going to have the top and the bottom. Now that is going to have a side of 5 and y. So if I multiply those together, I'm going to get 5y. Okay, so I've got 5y for the top and 5y for the bottom. So I've got 2 of those, isn't it? I've got 5y times 2. What about the front and the back face? Now again, the front and the back, this face here and the back one, okay, are going to be 5 times y again. So I'm going to have 5y for the front face and another 5y for the back face. Okay, so what's that all together then? So 5 times 5 times 2, 5 times 5 is 25, times 2 is 50. 5y times 2 is 10y. 5y times 2 is 10y. So adding all that up, I'm going to get 20y plus 50. Now I'm told that the total surface area of the cuboid is 200. Okay, so that means that 20y plus 50 must be equal to 200. Okay, so subtract 50 from both sides. That's going to tell me that 20y is equal to 150, and then dividing both sides by 20 then. That's going to tell me this cancels with this, leaving me with y equals 15 over 2, 7.5. Okay, so that's the length y is 7.5. So then the volume of the cuboid is length times width times height, which is 5 times 5 times 7.5. So reaching for the calculator because I'm feeling a bit lazy. 5 times 5 times 7.5. That comes out to be 187.5. Okay, 187.5 cubic centimeters. Part B says, in fact, the total surface area of the cuboid is smaller than 200 centimeters squared. What does this mean about the volume of the cuboid? Tick one box. Okay, so if you remember, we had the formula 20y plus 50 equals 200 to work out y. Now, if 200 is not 200, but it's smaller than 200, that must mean that when we found that 20y is equal to 150, if 200 was smaller and I took 50 away from it, I'm going to have an even smaller number here, which means that y must have been smaller than 7.5 then. Okay, so it's not 7.5, it's smaller than 7.5. So then the volume, which was 5 times 5 times y is going to be smaller than it was. So then we multiply those 3 things together, the volume is going to be smaller than it was. Okay, so it is smaller than the answer to part A. In question 13, I've been given a triangle with algebraic sides. I've got 3x minus 9, 2x plus 4, and 5x minus 11, and I've been told that given that the ratio of AB to BC is 1 to 2, show that AC to BC is 3 to 4. So AB to BC, AB is that length there, to BC is a ratio of 1 to 2. Okay, now I can use that information, the 2 sides and the 2 ratios, probably to find out what x is, I should imagine. Let's give that a go. So BC basically is twice as big then as AB. So if I take AB and double it, I should get BC. So if I take AB, 3x minus 2, and I double it, I should get BC. So I formed a linear equation in x here. Removing the brackets, 6x minus 18 is equal to 5x minus 11. Let's collect the x's on this side and the numbers on this side. So 6x minus 5x is equal to 18 minus 11. So x is equal to 7. Okay. Now, remember, that wasn't what I was meant to find. It didn't say find x. It said show a to c is, the ratio of a to c to b to ac to bc is 3 to 4. But having now evaluated x, it should make that job a little bit easier. So, if x is 7, then 5x minus 11 is going to be 5 lots of 7 minus 11. 5 7s are 35. Take away 11 is 24. And 2x plus 4 is going to be 2 lots of 7 plus 4. 2 lots of 7 is 14 plus 4 is 18. So now I make A to C 18 and B to C 24. So then the ratio of those two sides then is going to be 18 to 24. So AC to BC is 18 to 24, but 18 and 24 both have a common divisor. They're both in the 6 times table. So dividing both sides by 6, 18 divided by 6 is 3, and 24 divided by 6 is 4. So there we go. We've shown that AC to BC is in the ratio of 3 to 4. Question 12. A, B and C are 3 points on a circle. The radii from A, B and C are shown. Is AC a diameter of the circle? You must show your working. Okay, so it's not drawn accurately, but we've got 3 angles given, and we need to see if 5x plus 40, then this one here resolves to 180 degrees. And if it does, then AC is going to be a diameter. But if that angle is not 180 degrees, then it's not a diameter, is it? Okay. Now we've got 3 angles meeting at a point, basically. So we've got 5x plus 40, we've got x, and we've got this 2 lots of 2x plus 20. Okay. And we know that angles meeting at a point sum to 360. So angles meeting at a point sum to 360. Okay, so that means those 3 angles added together should be 360 degrees. So the 5x plus 40 plus the x plus the 2 lots of 2x plus 20. So the yellow one, the green one, and the blue one added together should be 360. Okay, so let's try and collect everything together. Before I do that, I'm gonna have to multiply out this bracket here, aren't I? Okay, so I might collect the 5x and the x together. So that's 6x plus 40 plus, I've got 2 lots of 2x, which is 4x, and I've got 2 lots of 20, which is 40. So that's equal to 360. And then I've got my 6x and the 4x, and I've got 40 and 40. So adding those together, that gives me 10x plus 80 equals 360. Okay, so I've got a linear equation in x. Let's go on and solve it. Let's take 80 away from both sides to start with. That will cancel, and it'll leave me with 10x on the left. 360 minus 80, that's 280, isn't it? So then if I divide both sides by 10, cancel. Leaves me with x is equal to 280 divided by 10, that is 28 degrees. Okay, now I've not answered the question, have I? The question was, is the yellow angle a straight line? So therefore AC is a diameter. So if x is 28, then 5x plus 40 then is going to be 5 lots of 28 plus 40. 5 lots of 28 is 140, plus 40 is 180. Okay, so that means that that angle is 180 degrees, which means AC must be, therefore AC is a diameter. Question 17. Here are two rectangles. The area of the shaded rectangle is a quarter of the area of the large rectangle. Work out the value of x. Okay. So I suppose the large rectangle is fairly straightforward. So the area of the large one, before you take the grey bit out, is going to be length times width, isn't it? Which is going to be 12 lots of x plus 2, which is 12x plus 24 then, isn't it? Okay. So then the grey bit then is a quarter of that then. So this one here, the area is going to be a quarter of 12x plus 24. So what's that then? That's going to be a quarter of 12x is going to be 3x, and a quarter of 24 is going to be 6 then, isn't it? So it's going to be 3x plus 6. So we've got 3x plus 6 in here. Okay. Now we haven't used this information yet, have we? That this distance and this distance is x. So I think what we're going to need to do is we're going to have to find this distance and this distance in terms of x, and then compare them to that 3x plus 6 that we've got in the middle. That's what we're going to have to do. Okay. So this length here, the green length, is going to be well, we know that the whole length is 12. If we take away x, this is going to be 12 minus x, isn't it? Okay. And the blue bit over here, the other side is x plus 2. So if we take away x, that is going to be 2. Okay. So if we multiply those two things together to find the area, we can see that the area is also going to be 12x minus x times 2, which is 24 minus 2x. So area, we know the area from before, using like a quarter of the big one, we know it's 3x plus 4, but we also know that the area is equal to 2 lots of 12 minus x. In other words, it is 24 minus 2x. Okay. So what we've done is we found the area in two different ways. So we can kind of solve these as simultaneous equations. If the area is 3x plus 6 and the area is 24 minus 2x, then 3x plus 6 must be equal to 24 minus 2x. So these two things here have to be equal to each other, okay? Because they're the same area. We just found it in two different ways. Okay, so what we're going to do is we're going to equate those and say that 3x plus 6 must be the same thing as 24 minus 2x, isn't it? Because it's the same rectangle. It's the same area. They must be the same, even if they look different. So then, equating those, we can then rearrange for x and solve, can't we? So add in 2x to both sides to start with. They're going to cancel. It's going to leave me with 5x plus 6 equals 24, and then taking 6 away, minus 6 minus 6. It's going to leave me with 5x equals 18. So then x is going to be 18 over 5 then, isn't it? So 18 divided by 5, that is 3.6. So x is going to be 3.6. Question 12. The rectangle has length 2x plus 5 centimeters and width x minus 2 centimeters. The rectangle has an area of 35 centimeters squared. Use algebra to find the value of x. Okay, so area of a rectangle is just length times width, isn't it? Okay, now we know the area. We're told it's 35. We know the length. It's 2x plus 5. We know the width. It's x minus 2. Okay, so solve for x. Okay, so we've got a quadratic coming on, haven't we? So we've got a pair of double brackets that we're going to need to multiply out. So that times that, that times that, that times that, that times that. So I'm going to get 35 is equal to 2x squared plus 5x minus 4x minus 10. Okay. Then what I'm going to do is going to collect everything on one side. So that 35, sitting there, I'm going to move over to the other side. So collecting like terms, 2x squared, 5x take away 4x is x, minus 10 with my other 35 coming over is going to be minus 10 minus 35, which is minus 45. And that's going to be equal to 0 because there's nothing left on the left. Okay, so I've got 2x squared plus x minus 45. Can I factorize that? I hope so. Okay, so common factor, well, common factor pairs of 45. Got 1 and 45, 2, no, 3, no, yeah, 3 and 15. 5's got to be in there, isn't it? 4, no, 5 and 9. 6, no, 7, nope. 8, nope. So, which one of those pairs is going to work? Now remember, I'm going to have 2x and x in here, so the order I put them in is going to affect the middle one as well, isn't it? I'm thinking it's going to be this pair here. Okay, because if I put the 5 at the end here, plus 5, it's going to be multiplied by the 2x, give me 10, and then the 9 here, which is negative, 10 subtract 9 is going to give me the 1 in the middle. So it's 2x minus 9x plus 5, okay? That's equal to 0. So that's going to give me solutions of x equals 9 halves, 9 over 2 here, which is 4.5, or x equals minus 5. Okay? Now, does that make sense in this question? Because if x was minus 5, then up here, look, I would get 2 lots of minus 5, minus 10 plus 5, which is a negative number, and I can't have a rectangle with a negative value in reality, so that one is not a solution. Okay, it's a solution to my quadratic, but it's not a solution to this problem. Okay, so I'm just going to ignore that one. I'm instead going to use the x equals 9 over 2 or 4.5. Okay, so x is 4.5. Question 26. Here is an L shape. All dimensions are in centimeters. Okay, so we've got this shape here, and we know 2 of the sides, and 2 of them are given algebraically. Now we've got some missing sides down here and down here, but we can usually work those out from the other sides, can't we? So for instance, this horizontal distance is the difference between 10 and x, so that side is going to be 10 minus x, and this one up here is going to be the difference between 9 and 3x plus 1, so it's going to be 9 take away 3x plus 1. I don't even know if that's relevant yet. I should go really and find out what the question is. It's probably got something to do with it, isn't it? So the area of the L shape is 65 centimeters squared. Work out the value of x. Okay, so we need to work out the area of this square shape, this L shape. So what I can do is I can divide it into 2 parts and then work out the 2 parts and then add them together then, can't I? I'm just trying to decide which way around to do it, if any of it gives me nicer numbers than anything else. I don't think so. Let's just divide it this way. At least I get one nice piece. So that part there is 9 times x, isn't it? So that part there is going to be 9x. And this other section is going to be 10 minus x times 3x plus 1. So that's going to give me a quadratic, isn't it? So this is 10 minus x times 3x plus 1. I'd have to work out what that is. So the combined area then is going to be those two things added together. So area of my L is equal to my 9x plus the brackets, which now I've forgotten again what's in them. 10 minus x and 3x plus 1. 10 minus x and 3x plus 1. Okay, now I know that's equal to 65. So I suppose I just need to multiply these out, these two brackets, and combine it with the 9x and the 65, and then we're going to have a quadratic that we can then solve for x. So that's my plan of action. Okay, so let's multiply out the quadratic first. So my 65 then is going to be equal to 9x, which was already there. Then I've got 10 times 3x, which is 30x. So plus 30x. I've got 10 times 1, which is plus 10. I have got minus x times 3x, which is minus 3x squared. And I've got minus x times 1, which is minus x. Okay. So just collecting like terms on the right first. I've got 30x plus 9x take away x, which is 38x. I've got my minus 3x squared, and I've got plus 10. Okay. Now, because it's a quadratic and I want to solve it, I want to get everything equal to 0. And the easiest way to do that is to move everything onto the other side so that my minus 3x squared term becomes positive. So I'm going to move all three terms over the equal sign. Now, put them in order, moving the minus 3x squared over first. That becomes 3x squared, positive 3x squared. My positive 38x becomes minus 38x. And my 65 subtract 10 becomes plus 55, and that is all equal to 0. Now it'd be lovely if this factorized, and it's always worth giving it a decent go before you give up and go for the formula approach. So if it did factorize, we would have 3x here and we'd have x here. Factors of 55. What are the factors of 55? Not that many, I suppose. There's 1 and 55, and there is 5 and 11, and I think that is probably about it. So can I make 38 by popping those numbers in somehow? Now, because we've got a positive last term and a negative term in the middle, the only way that can happen is if both terms here are negative. So these both have to be negative numbers. So let's just try those numbers in. If I put the 11 in here and the 5 in here, then 3 times 11 would be 33, and 5 plus your 5 would give you minus 38 then, wouldn't it? So that does actually work. Happy days. I don't have to do the formula. Okay, now if in an exam you struggled and you couldn't find, or you tried to factorize it and you fail, you can always fall back on the formula. There's no reason why the formula won't work. It's just long. Better to factorize it if you can and avoid using the formula if you can. But if you can't, then you just have to bite the bullet and do the formula. Okay, but we managed it here, so that's good. So if 3x minus 5 times x minus 11 is equal to 0, if two things multiplied together give you 0, it means that one or the other of the things must have been 0 to start with. So 3x minus 5 equals 0. What does that mean? That means 3x is equal to 5, x equals 5/3, or x equals 11. That one's easy. So they're my two solutions, x equals 5/3 or x equals 11. Now, just because a number is a solution of a quadratic doesn't necessarily mean it's a solution to your problem. Let's just go back and have a look at 5/3 and 11 in situ. So going back and looking at the diagram. Okay. Now, if x is 5/3, no problem. But if x is 11, what do you notice? Well, if x is 11, then this side here is 10 subtract 11, which is -1. And now in the context of this question, x equals 11 doesn't make any sense. Okay, so whilst it is a solution to that quadratic, it is not a solution to the problem. So we're going to have to rule this one out. And I'm going to write underneath, not possible, to show that I considered it and decided against it. So the answer is 5/3. Question 14. Here are two squares A and B. The length of each side of square B is 4 centimeters greater than the length of each side of square A. The area of square B is 70 centimeters squared greater than the area of square A. Find the area of square B. Give your answer correct to 3 significant figures. You must show all your work in. Now, when you know things about something but you don't know the things themselves, this is a good time when you should be using algebra. Okay, so I don't know the side of length A, but I know that B is 4 centimeters greater than the side of length A. Okay, so that's a classic example of where you should be using algebra. So we're going to say that the side of square A is going to be x, and therefore we know that the side of square B, which is 4 centimeters greater, is going to be x plus 4 then, isn't it? Okay. The area of square B is 70 centimeters squared, so we know what this area is. It's 70 centimeters squared. Okay. Sorry, greater than the area of square A. Okay, now I don't want to create a new thing and say this is A and this is A plus 70. What I think I'm going to do is I'm going to work out what the areas of each of those things are, given the things I already know about them. So I can work out the area of a square if I know its length. So I don't need to introduce any more algebraic terms. I just need to work out what these two lengths are, and then I can bring them together with that second statement there. Okay, so area A is equal to x squared, isn't it? And area B is equal to, well, it's going to be x plus 4 times x plus 4. Okay, if you know your perfect square identity, that's very easy to multiply out. That's x squared plus 8x plus 16. Do you know your perfect square identity? A plus b all squared equals a squared plus 2ab plus b squared. So when I multiply out a double bracket like this, I just know that the first term is going to be this thing squared, my last term is going to be this thing squared, and the term in the middle is going to be those two things multiplied together and doubled. So the first term squared is x squared, the last term squared is 16, and the middle term is going to be 2 times x times 4, which is 8x. Okay, so that's how I do it. Otherwise you can do, like, you know, normal FOIL like you normally do, but it just kind of speeds things up if you know that if you know that identity. Okay, so if you didn't, one for you to put into your toolbox. Right, so let's crack on. So I know the areas now in terms of x, and I'm told that the area of side B is 70 centimeters squared greater than the area of side A. So that means if I take the area of side A and add 70 to it, it should be equal to the area of side B. Okay, in other words, x squared plus 8x plus 16 is equal to x squared plus 70. Okay, so this thing is equal to this thing add this thing. Okay, so you can see where all the bits came from. Right, so then I can well, straight away I can cancel these off because x squared equals x squared, so they can disappear. And then I just need to solve it. It's a linear equation, isn't it, in x that I can solve. So if I take 16 away from both sides, I'm left with 8x, because they'll cancel, leaving you 8x. And on the other side, I'm going to get 70 take away 16, that is 54. And then x then is 54 divided by 8. 54 divided by 8, that is 6.75. Okay, so we're not quite done, are we? If x is 6.75, remember we wanted to find the area of square B. Now, we found x, which is the length of side A, so that's 6.75. So that means that the length of side B, which is 4 centimeters more, that must have been 10.75. And so the area of B is going to be 10.75 squared then, isn't it? So what is 10.75 squared? 10.75 squared is 115.56. To three significant figures, I'm going to round that up. I'm going to say that is 116 then. 116 centimeters squared. Question 23. The diagram shows a rectangle split into 3 triangles. And you can see that the sides of our rectangle have been given algebraically. We're told that the total shaded area is 7.5 centimeters, and we need to work out the value of x. Okay. So the shaded area then is going to be the area of the rectangle minus the area of that triangle, isn't it? The white triangle. So the area of the rectangle is going to be my two sides multiplied together, 2x and 3x plus 1. So 2x and 3x plus 1, my two sides multiplied together. And my area of my triangle is going to be half base times height. So that's going to be half of 3x plus 1 times 2x. So 2x times 3x plus 1 is going to give me 6x squared plus 2x. Half of 2x is x, and x times 3x plus 1 is, I'm going to get minus 3x squared minus x. Okay, so subtracting and collecting like terms, 6x squared minus 3x squared is 3x squared, and 2x take away x is x. So my shaded area is 3x squared plus x. Now we're told that the total shaded area is 7.5 centimeters. So 3x squared plus x equals 7.5 centimeters. Now we need to solve for x. So let's bring the 7.5 over to the left hand side. So I've got 3x squared plus x minus 7.5 is equal to 0. I might just multiply everything through by 2 to make it a bit easier. I don't really like dealing with that 7.5. Let's make it 6x squared plus 2x minus 15 is equal to 0. So can we factorize this? So I've got 6x, so that could be 6x and x, or 3x and 2x at the beginning. So I have 6x and x, or 3x and 2x at the start, and then at the end I've got 15, so I could have 1 and 15, or I could have 3 and 5. Now there's a combination that delivers 2x in the middle. So 6x times 3 is 18. 18 take away 5 isn't going to work. No, I don't actually think there is. That's a bit annoying. So plan B is to, if I can't factorize using double brackets, the next thing to do is to use the formula, isn't it? So instead, I'm going to use x equals minus b plus or minus the square root of b squared minus 4ac over 2a. Hooray! Really happy about this. So I'm going to sub the values in from my expression. So a is 6, b is 2, and c is minus 15. So there, We need to sub those in carefully. So minus b is going to be minus 2 plus or minus the square root of 2 squared minus 4 times a, which is 6, times c, which is minus 15, all divided by 2 lots of 6. Okay, what's that equal to then? So that's minus 2 plus or minus 4 squared minus, well, 4 times 15 is 60, times 6 is 360. Going to flip the sign because I've got a minus and minus. So it's 4 plus 360, which is 364, divided by 12. So time to reach for the calculator. Minus 2 plus the root of 364 divided by 12 gives me 1.42. So x equals 1.42. Or the other solution I get when I have minus 2. So minus 2 minus the root of 364 divided by 12, which is minus 1.76. But actually in this case that doesn't make a lot of sense, because I can't have a negative x for this one because it's an actual thing. So I'm just going to rule that one out. Can't be that one. So it's going to be x equals 1.42. Can't be negative. Now, according to the mark scheme, you'd actually lose a mark if you'd have written down both answers. So it was good that we were sharp and we spotted that. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again.